Assalamu alaikum everyone. My name is Arsalan Farrukh and I am a teacher of math and physics. In this video, we will discuss how to represent a locus of points in an Argand diagram using a complex number. You have to identify certain forms, like if you are given modulus of z minus a is equal to r, and you have to see all the points which satisfy the complex number z. It will always be a circle. You have to just learn this particular form, recognize this particular form, that you have a modulus of z minus a, some complex number in place of a, equal to some constant value. So in that case, you will always equate whatever is inside the modulus sign to 0, get z, and whatever you would get as z will be your center of a circle, and you draw a circle with radius r. So this form would represent a circle with center a and radius r. Like for example, if I am being asked to represent locus of all the points satisfied by this particular equation. So first I will find out the center of it, which is going to be z minus 3 plus 2 iota equals 0, or z is equal to 3 minus 2 iota. So 3 on the real axis and minus 2 on the imaginary axis, I'll get the center of that circle. After I have found out the center of the circle, I will identify that I have to make a circle of radius 1. So with this point as center, I'm going to make a circle of radius 1. Just a little bit of a discussion on why this forms a circle. So see, once you've drawn a circle and you pick any particular point, so this is basically your z and this is your a, and this vector over here, that's going to represent z minus a, and its modulus is going to be equal to the radius of the circle. So if you pick any point and you draw a complex number z, then z minus a will always have a radius 1 when you draw a circle like this. The same thing could be represented in the form of inequality as well. Like you could be asked to represent all the points less than equal to r. So that means that you still draw a circle, but you know that less than equal to r would be all the points which are inside the circle as well. Or greater than equal to r means all the points which are outside the circle. So in these cases, you have to represent loci in the form of shaded areas. So less than equal to r means inside the circle, and greater than equal to r means outside the circle. While drawing these diagrams, you also must remember that a solid boundary is always considered part of the shaded region, and a dashed boundary is always considered part of the unshaded region. Like if I had to draw z minus a just less than r, so I had to exclude the boundary, and to exclude the boundary I would have to make it part of the unshaded region, and hence I will draw it as a dashed circle. For to be able to draw these kind of diagrams, I would highly recommend you to carry your geometric box. Even if you don't have to draw it accurately, drawing it as accurate as possible will help you do the remaining parts of the questions more easily. Similarly, if let's say you have to draw a locus of points which is z plus 2 minus iota is less than 3, so you again equate this to 0. You get minus 2 plus iota as the center of the circle, and with that center you draw a circle radius 3, and since it's less than, you will consider all the points inside the circle, and since it's not less than equal to, so you have to exclude the boundary, make it part of the unshaded region. So that's why this boundary is in the dashed curve. The second form that you must know is argument of z minus a is equal to alpha. What you're going to do in this case always is that you again equate this to 0, and you will get a point. Whatever is the point you're going to get, with that point as a starting point, you will draw a half line at an angle alpha. Like if let's say you are being asked to represent locus of all the points such that z minus 2 plus 3 iota is equal to pi by 6. So first I will get this point by equating it to 0, which will be 2 minus 3 iota. So once I get a point 2 and minus 3, 2 on the real axis and minus 3 on the imaginary axis, I will draw a half line. This is going to be my reference point, a horizontal line, and at that point I'm going to draw an angle of pi by 6 radians. So pi by 6 is 30 degrees. You can use a protractor if you want to draw it more accurately, but I mean, if it's a sketch, you can just approximately make it 30 degrees and label it as pi by 6 radians. Whenever you have to sketch a locus of points of the form argument of z minus a is equal to alpha, you equate the brackets to 0. That will be your point of reference, and at that point of reference you draw a dashed horizontal line to measure the angle, and then you draw a half line at that particular angle. Sometimes you could be given inequality for this case as well. So if it's less than alpha, so any point that's below this line that you've drawn is going to be considered part of the locus, and if it's greater than alpha, then any point that's above the line, that will be considered as part of the locus. So basically, you know that the total angle is from minus pi to pi. So any point above the line would be all of these points, and any point below the line are going to be all of these points. Just a little bit of a justification as to why is this so. So you know that this is your point A, and you are claiming that this is the representation of z. So if you draw a z over here, this is going to be z minus a. And you can see that z minus a has an argument alpha. So every point along this line will be such z that satisfies this equation. And that's how you draw the locus of all of these points. So similarly, if I had to draw the locus of all of these points, I knew it had to be an inequality. So I first of all found the point after equating the brackets to 0, minus 3 plus 4 iota. That will be my starting point. And then I will draw a half line with a reference of 0. This is my 0 reference angle. I measure an angle of pi by 4 radians. That's 45 degrees. So you can approximate it, and then once you have drawn this half line, then you would know that all the points have to be above the line. So from till pi, every point above the line is going to be considered as part of this locus. Another possibility of drawing a locus is when you have modulus of z minus a is equal to modulus of z minus b. So you have z here, you have z here, and then you have two complex numbers represented as a and b. So you will equate both these to 0, and you will get a z value which will represent your 2 points. So you will draw a point A, and then you will draw a point B, and then after finding out these 2 points, you will draw a perpendicular bisector of these 2 points. So once you will draw a perpendicular bisector of these points, they will always satisfy this particular equation. Now a bit of a discussion as to why is that so. So if you consider any point z over here, then you would know that this line is going to be z minus b, and this line is going to be z minus a. And on a perpendicular bisector, this length and this length would be equal to each other, and I wanted these two moduli to be equal, and that is why every point lying on this particular perpendicular bisector must be satisfying this equation. So if it is in the form of inequality, whichever is smaller, the points are going to be closer to that. So if it's z minus a is less, so that means the modulus of the points nearer to a would be smaller. So you will shade a region that is nearer to a. In this case, if it says c minus a is bigger, so that means the points nearer b would have a smaller modulus. So you will identify all the points which are nearer to b. So you draw a perpendicular bisector and you shade a region. Let's have a look at a few more examples. Modulus of z equals 5 would be origin, center, and radius 5. Modulus of z minus 3 iota equals 2 would have 3 iota as a center and radius 2. Modulus of z minus 1 plus iota equals 1 means it will have a center as 1 minus iota and radius as 1. Similarly, if I have something like this, I equate this to 0, 2 plus 3 iota becomes a center, and I draw a circle with radius 4. So this is 2 plus 3 iota, and then I draw a circle with the radius 4 with that. So I can do that with all of these forms of the loci. Similarly, if I have to sketch a locus of these kind of points, so I know that I'd equate this to 0, I'll still get an origin, and then I'm going to draw a half line at an angle of pi by 4. Or I equate this to 0, I get minus 1 plus 3 iota. So minus 1 plus 3 iota would be my starting reference point, and from that point I will measure the angle of negative pi by 6 or negative 30, and these are going to be all the half lines representing these points. If I have something like this, I equate this to 0, I get 3 minus 2 iota, and on 3 minus 2 iota, I'm going to draw a half line at an angle pi radians. If you have modulus on both sides, so you equate this to 0 and this to 0, you will get 2 points, and once you will get 2 points, you'll draw a perpendicular bisector that will be satisfying this particular equation. Or you equate this and this to 0, you will get 2 points again, and then you draw a perpendicular bisector of those 2 points. Let's have a look at some examples of inequalities. Like if I've been given something like this, so I know it's like something related to radius if I deal with them individually. So I take 1 minus 3 iota as my center and draw two circles of radii 4 and 6. So it says modulus of this is greater than equal to 4, so the point should be outside the radius 4, and less than equal to 6, so the point should be inside the radius 6. Similarly, if I have to sketch the loci representing this particular inequality, I'm still gonna consider this as my starting point, 2 minus iota. I'm gonna draw two lines, two half lines, one at pi by 3 and pi by 2, and I know that the angles have to be greater than equal to pi by 3 and less than equal to pi by 2. So this is my starting point. I make a line at pi by 2, and then I make a line at pi by 3, and greater than pi by 2 and less than pi by 3 would be between these two lines. Similarly, I have another example. I will again equate this to 0. I get 2 minus 3 iota as my center, and then it has to be greater than minus pi by 3, that is minus 60, and less than minus pi by 6, that's minus 30. So anything between these two lines is going to be considered as part of the locus here. So guys, I hope this video was helpful towards making you understand how you represent the locus of points of a certain equation in an Argand diagram. If this was helpful, I'd really appreciate if you give the thumbs up and you subscribe to my channel and you share it with your friends.